All right, thank you. Good afternoon, welcome. My name is Alex Sutton. I am a program manager on the Azure HPC team, where I focus on AI and HPC infrastructure and solution strategy. The idea behind Batch AI got started about a year ago when we first introduced the K80 GPUs on Azure. We got a lot of calls from AI researchers and data scientists. I wanted to take advantage of this new capability in Azure, but had no idea how to use Azure. How do I deploy VMs? How do I manage storage? How do I connect things up with networking? So we created a set of Python scripts that deploy deep learning frameworks into containers and then ran jobs on top of Azure Batch. This is what we called the Azure Batch Shipyard project. Got a pretty good reception from customers, AI researchers at a number of major companies, as well as within Microsoft. People that wanted to get their work done, focus on their models, focus on their science, and didn't want to deal with the infrastructure. They said, wow, this is great. You should really turn it into a service and give us a full SDK and API. At the meantime, we started talking to groups within Microsoft who had the same need. The amount of AI training, GPU use, basically cloud use that our internal teams need to do is staggering, and none of them want to manage the infrastructure either. So we started working with the AI tooling team within Microsoft, the machine learning team, and generated Azure Batch AI, which is really about helping you, take advantage of the cloud, take advantage of the resources that we have, and do industrial strength AI with the power and tools that Microsoft does. So I'm excited to talk with you more about this today. I talk a lot about scale because both our team lives for scale and really wants to make it easy, and I think it's also the kind of the secret sauce behind a really powerful AI. You need to train with larger and larger data sets, and you need more and more computer resources. Compute resources to do experimentation, figure out the best network, figure out the best hyperparameters, and do it again and again and again, because you're really never done. Scale is really important, doing things in parallel, because AI development is very much an iterative process. It starts with someone ideating, maybe working on their laptop, moving up to a GPU, starting to figure out what their algorithm is, how to best solve that problem. Then you really start to train small data sets, larger and larger data sets. Some of the teams at Microsoft are training for days, weeks even, on hundreds and now thousands of GPUs. When we talk with our teams in Bing and Office, they also have a very strong pipeline for how I bring things from that researcher to the data scientist and into production. So if you start thinking about AI as part of your application pipeline, maybe I've got a handoff from the AI researcher or expert handing off a model to a data scientist who's then going to go and specialize it further, go in, tune the model, figure out that best trade-off between performance and accuracy. As I'm developing new models, A/B testing, see is that new one going to work, and eventually start to go and run it in production. But you're never done. You're collecting telemetry then. Maybe you're doing a reinforcement learning and actually going and adapting your model as you run it. There's these iterative stages at each step. You may share a large pool of GPUs, but it's never enough. The usage spikes up and down based upon product need, where you are. We kind of evaluate things internally at both. What's the scale that you need when, and what's that velocity of getting from idea into production or change into production. And the researchers and data scientists want to focus on that part of the problem, not managing the infrastructure. The reason why is the infrastructure can be hard. I work in the infrastructure team at Azure. We like it, but our mission is to make it easier for everyone else to use. And we're coming at it from an HPC perspective, where at the last 15 years at Microsoft, we've thought a lot about how do I manage clusters, how do I get scale. We're the team really pushing the limits of scalability in Azure, deploying clusters of 40,000 CPUs regularly, hundreds and even thousands of GPUs. We think about how do I go build and maintain those clusters? How do I schedule jobs when I have a lot of work? How do I manage data, particularly if I'm training at scale? There's also cost. While the researcher wants to use a lot of GPUs, someone's paying for that budget too. And then finally, the training's not this thing unto itself. It's part of larger workflows that everyone wants to run. If I drill down to these, there's challenges in each one of these steps. On the cluster side, I've got to go and provision those virtual machines. Make sure I've got the right NVIDIA drivers, the InfiniBand drivers. If you're running at multi GPUs at scale, how do I get the frameworks, the libraries, the other tools that I need on those machines? While I'm talking about Batch AI, one of the feedbacks that we got from our internal teams is they often want to SSH into those boxes, go and develop their models there, and then make sure that that same environment is set up when they go then run in batch mode at scale. Well, if you think about a single user, do I ever need to queue and schedule work? Well, maybe if you want to run an experiment of hundreds of jobs and only have a small number of GPUs, or if you want to share a set of GPUs across your group. On the scheduling side, we have awareness of how to schedule multi-GPU jobs running MPI, and then also a system that can monitor for failures and requeue work when problems happen. On the data side, once I am scaling to multiple GPUs, I have to think about how do I get my training data to all the machines? Do I copy it? Do I have a shared file server? What about output logs? How do I get to a place where I can go and monitor and access them and figure out which model or which approach was best? And if you're doing this in an enterprise framework, how do you think about the security and compliance for the data? Something that's very important for the internal teams, where some of the data that someone is training a model at might not be something that the data scientist is allowed to look at. So how does a system allow someone to train at scale, use the authorized data sets, and have only access to what they're allowed to? On terms of cost, being able to scale up and down when I need GPUs, and probably most importantly, don't leave a cluster running over the weekend idle and driving up the bill. You also want to take advantage of different pricing models in Azure. We have a lot of customers interested in our reserved instances where you can get a large number of machines at the best price, but you've committed to it 24 by 7. So it starts to look like more of a traditional HPC problem, where I have a fixed set of resources that I want to keep really, really busy with the most important work first, the experimental work second, and then be able to scale it up when I need even more resources. Or on the other side, if we happen to have spare capacity in Azure, take advantage of the new low priority VMs and run additional work at really low cost. And then thinking about, well, training is a really hard and important thing. It's part of a bigger workflow. How does it integrate with tools? How does it get into workflows? And really think about how can that developer go from laptop to cloud to production. So we created the Azure Batch AI service. Really think about it as a managed service that helps the AI researchers, the data scientists, train and test their deep learning or machine learning or any AI model in the cloud. The idea is you can get a cluster of GPUs or CPUs for yourself to run many jobs in parallel and at scale to reduce your training time. And it's really, I think about it as this is a problem we've had to solve for all of our internal teams. I want to make sure that you can do your AI with all the power and scale and tools that we're using internally at Microsoft. Let me just jump right in and show you how easy it is to submit a job with a batch. So we see here is I've got a cluster with three clusters with GPUs. Let me just use the command line and submit a job, a TensorFlow job to one of these. Now the real test is, can I remember the commands? Job create, we'll give it a name of, what's I calling it, TensorFlow job. We'll run it on DSVM, and we use the template TensorFlow host. While this goes, let me show you the configuration file for the job that I'm going to run. So I'm going to run a TensorFlow job, and what we have is you can specify parameters on the command line or in a configuration file. What you see here is the configuration for my job, where I want the standard out and standard error to go, where I can find the training data and the scripts for my job. What I've done in the pool here is created an Azure Files shared file share that I then mounted on each of the compute nodes for training, and that's where I'm going to put the output files, the models, and where I can find my training data. Then I have the configuration for a TensorFlow. Here I'm running on two nodes, and I've got the configuration for the master, the worker, and the parameter server. Let's just go see here, and the job was submitted. I can Azure Batch AI. Strange on the screen, but you can see there's the job that I started. Let me just take a peek in Azure Storage Explorer. There you can see the input files for my job. Go into the file share for the demo jobs. There's the TensorFlow job I just created. You can see the standard error and standard out being created for that job. Looks like it's just getting started. Put files for the model going there. Anyway, I will go and we'll talk more about each of the things that I just did. One of the questions that we asked is, should we just build this on batch? Should we just provide script? And the feedback for users is, I don't want to program. I don't want to figure out your infrastructure. Give me an experience really focused on the problems I'm trying to solve with AI. In the case of jobs, it's thinking about three different usage models. That interactive model where I SSH to the VM, we've set it up, we've got access to all of the data, all the software is installed. Someone can go and run the jobs interactively and debug if you're more in a development phase. An iterative model where I'm submitting a job, I'm monitoring the output, stopping it, tweaking it, running it again, or batch jobs are either hyperparameter optimization or very large training runs that can run for days or weeks. They want to have a framework-specific configuration. Well, we can run any code, any script that you want to run. We're actually building knowledge of the major frameworks into the system. CNTK, TensorFlow, Chainer, Caffe, Torch. So we can do a good job of having knowledge of those, do specializations like in the case of a TensorFlow, perhaps run the different roles on different size of VMs, but have more configuration configuration flexibility in the system instead of you having to write code. In the case of batch, because it deals with a single VM type in a pool, it couldn't easily handle the TensorFlow example where I might need two or three different VM sizes. We have flexibility of of a deployment, either in virtual machines or containers. The batch shipyard approach that we started with was all container-based. I really like the idea of using Docker containers for deep learning, because it's an easy way to package up all the libraries, scripts, frameworks, and tools that you need. The feedback in the private preview that we've had for the past few months is people like virtual machines too, because they can go and build it once and then go and deploy it. Docker is still fairly new to people. We've provided a lot of guidance on how to build containers, but VMs work great too. The other advantage of VMs is we're doing a lot of our examples with the data science VM, the DS VM, so a lot of the software is already installed, and also really makes it easy to go and start developing on your laptop and then going and running that same job in the cloud. So containers, virtual machines, or you can also run a script and install whatever you want if you don't want to go and build your own packages. Several shared storage options that I'll talk about later, including managing an NFS server if you want to be able to go and scale out to multiple GPUs, and Azure Files isn't quite delivering the performance that you need. And then importantly, thinking about the SDK and programmatic needs, so you can go and use Batch AI standalone or integrate with bigger workflows or tools. It's built on Batch. We're using the name Batch for a couple of reasons. One is you're sort of training in a batch style, but it's also built on Azure Batch, which is our cloud scale resource management and job scheduling service. It was actually one of the first services built in Azure to solve MapReduce, rendering, and some other problems when Azure was first started. It's been in production for a number of years now, and customers are regularly doing compute runs at the 20, 40, 50, 100,000 scale, core scale. So it's very robust, is in every region around the world, and a great way for doing batch style type apps, but it's a programming experience. It's not an end user type of thing. The samples that we built with Shipyard was kind of a first step of doing an open source project for providing a higher level experience on top of Batch, but then we're taking it now one step further with AI. The general programming model with Batch is fairly straightforward. Specify what program you want to run, any parameters that get passed in, where to run it, the region, the number of VMs, and how many instances to run in parallel. The business model is fairly straightforward. Just pay for the compute that you use. There's no additional charge for using Batch or Batch AI. Supports standard VMs, and we're announcing at Ignite the general availability of low priority VMs with Batch. Think of low priority as the Azure equivalent of a spot pricing. If spare capacity is available in some region around the world for the size that you want, you can go and use those VMs at a fairly significant discount, though you can be preempted at any time. Let me go and show you one more demo, kind of a Python view. How many of you are familiar with Jupyter Notebooks? It's really a great way to share code, share examples. We're doing a number of our tutorials now and delivering them in a notebook. So we're going to have a bunch of samples that were being shown in a couple of other sessions here, and that plug into Azure machine learning, that you'll be able to go and walk through entire workflows of training. What we did here is take one of the standard CNDK samples and just wrapped it with the batch concepts. What I'm going to show here is the Python API and kind of how you would interact with a batch if you didn't take that CLI example that I showed first, but instead want to drive it from a script or a code. First step is to import the Batch AI library and storage. I've also got a configuration file with my storage account, the subscription that I'm using, and my Azure Active Directory Azure Active Directory credentials. So you can go and share source code like this and not have passwords or secrets in the code. I'm going to go and run this job on my cluster DSVM2. And I'm going to go and create an Azure file share if it doesn't already exist. Here I've already got that demo file share active. In this case, I'm going to go and create a new directory called CNTK scripts. If you saw these when I was on the storage page earlier, this directory did not exist. And then I can go and copy these Python files and CFAR data sets from my laptop up to that Azure file share. Go there, and then we have an environment variable that's set on all of the machines, the Azure, the AZ learning mount root. This is the environment variable that we can say, here's where we're going to mount a shared file server, here's where your training data can be, here's where the model outputs can go. So here I'm saying I'm going to put the standard out for this job in this location. And then the output directory for the models. This is the job configuration here. A couple of key things. Here I'm going to run on 8 GPUs, so 8 NC6s. I'm going to run a job preparation script where I'm going to go and grab the tar files from storage and copy the data locally to each of the nodes so the training goes a little bit faster. Here, I'm not going to use the virtual machine. I'm going to use a CNTK container. So we're going to pull down the CNTK container from the official repo. The first time a job that references this container is run, we will go and fetch it. If you run additional jobs on that same VM with the same container, it's effectively cached, and you don't pay that download and install time twice. And then finally, the command line settings that I want to run for CNTK. The configuration for CNTK is first, are you running a brain script or a Python script, path to the Python script, and the command lines that I want to pass in. In this case, where's my data? Where does the output go? CNTK can output logs for a tensor board, so we're also going to go and put those in the output file. And then we'll go and create the job. And if all goes well, we should create a job with the timestamp of now. The job is going to start, and while it's getting started, once it gets started, you see it's been assigned to eight nodes. It's going to get started, do the data preparation step, and run. In the meantime, let's just go and take a look at a couple of other things. We see this is job 2343. Let me go to the portal. We don't have the Batch AI portal experience deployed yet, but to show you that this is real and in production, I've gone to the resource group I created for the demo, looked at all of the resources, and you can see that there's a new resource for Microsoft Batch AI clusters. These are the 3 clusters that you saw on the command line earlier. Here's the job, 2343, so that job is running. I can also go to storage, so I can look at Azure files from the Storage Explorer that I showed. I can also go in through the portal. Go into demo, my subscription, jobs, and that's the job I just created. You can see the standard error was created for the job prep job that I ran that staged the data. It should soon be creating files for the standard out and standard error, and then the model files and tensor boards go there. Just go and see if the job has gotten started yet. Running alive. Let's
just see if there's any issues in the job prep stage. Nope, no errors there. That's good. Give this one more moment. Okay, so the job prep is running. Okay, so it untarred the data set, so hopefully the job should start in a moment. If not, let's move on. We'll come back to that in a moment.
So what we're trying to provide is a flexible way that you can go and train from configuration or code. The very first demo that I showed was using the CLI. I don't have to work in Python, learn how to script the service. I can drive it from a configuration file. One of the reasons that you can do this now is we've integrated Batch AI with Azure Resource Manager or ARM. So there's an ARM API. It'll go into the Azure command line. Authentication is then done through Azure Active Directory, which then supports various roles. So you can have one person who's in charge of deploying the cluster and managing the resources, a set of users that can deploy jobs, and a set of users that maybe can just read logs. There'll be APIs for Python, C#, Java, and REST. We've had customers using all of these APIs in the preview and using them to integrate into their workflows and tools. What was really kind of an eye-opener for us in the preview was once we deployed the Azure CLI and a set of recipes that help people get started with all of the major frameworks, it really opened up usage. And I think it was sort of that mindset of, yes, the data scientists may do their work in Python, but they don't want to go and figure out how do I deal with Azure in Python. This idea of simply configuring a file with what I want to go and run in my job, and yes, it's a JSON file, and we thought about YAML files, but in the end, here are the parameters that I want to run, submit the job, change the parameters, submit the job. It was a much easier workflow. In terms of data, kind of running jobs is fairly straightforward. I think one of the biggest challenges in any HPC-style engagement is how do you deal with data, and particularly data at scale. Unfortunately, there's no one easy answer that I can give you. We've got a number of different ways to work with data with Batch AI, and we'll have guidance in the documentation of what to choose when. Kind of one of the easiest things that a lot of people do is local disk. The N-series VMs come with, I think the NC6 has 700 gigabytes or a terabyte of local SSD. If your training set isn't that large, maybe if you're doing a lot of training over a time, copying the data down to a local disk may make a lot of sense. We're starting to do a lot more work with Azure Files because it's really just easy. It's there in the portal, it's available in Storage Explorer, I can mount it on my Linux or Windows VMs. We can also stream the output with the CLI. Kind of in a similar vein, there's a new project coming from the storage team that provides a Fuse driver on top of Azure Blob, so effectively providing an NFS-like experience directly on top of Blob storage. They'll be having a public release of this in the next couple of of weeks. One specific storage feature that we do have is the ability to deploy an NFS file server. So one of the specialized cluster types that we have is this NFS that's deployed and monitored as part of the server. You can then go and mount it from your laptop or MacBook, copy data in, look at the logs, run TensorBoard against it. And if that's not scalable enough for you, we have scripts to deploy a number of parallel file systems in Azure. Sample scripts for Lustre, Gluster, BGFS. We've got ARM templates, shipyard scripts. This is where the large AI research teams are coming to us and saying, how do we scale large-scale experiments of hundreds of GPUs, many of those at once with very large data sets. This is also sort of looking, in terms of performance, scalability, and cost. Local disk is cheap, it's there, you've already paid for it, but it's got limits in scale. Azure Files and Blob are very easy to use. Kind of you're paying for the storage and some transactions, and it takes you up to a certain limit. When you're using an NFS server or a parallel file system, you're paying both for the virtual machine that's handling the file system as well as the disks in the back. And at that point, you're probably using a premium storage. What's nice is we can scale these up and down as well. So we can go and deploy an NFS file server, train with it for days or weeks, and turn it off. If you want a parallel file system on the fly, great, we can go and spin it up. You can also go and turn off the VMs, keep the disks in storage, and rehydrate it when you're ready to train again. When you're working with it, you can connect to Azure Files, or what we do is we go and mount the remote volumes if you're using NFS or Azure Files, mount it into the VM, and if you're running your job in a container, we'll also go and mount that file system in the container. So as part of the node setup, you tell us what remote volumes you want created on that machine. We'll make sure it's plumbed through for the job. And then as part of your workflow, you do need to think about how do I get that data into the cloud. I'm going to go into blob storage and have a script to move it to the VMs or the file system. Am I staging from my laptop? Or am I using a tool like Azure Machine Learning that's going to help you go and do that data wrangling first and then move it and then go and train at scale with a batch AI. The CLI is pretty straightforward. 3 main objects: cluster, job, and file server. And then the basic operations of create, list, get details about that job or file server, see what output files were created, or get the remote login access for the VMs that I'm running on, terminate a job, and then delete a job or job cluster or file server. Go back to the demo and take a look. And I can see that my CNTK job did start to run. I think what happened is I reprovisioned the cluster when I was testing things, so the container had to be brought down, and that took some time to load. But I see this running now. I can go, let's see, is the job still going? This one takes about 15 minutes to run. Let me stop the notebook, show you one other operation is I can go and enumerate the files that were stored in the storage directory. So there's my standard out and standard error, as well as the files that are in the model output. So we can show how I can get it from the API. These are the same things that I'm seeing in the Storage Explorer or the portal here. Here are the standard out, standard error, and then I go in the output. I can see the models, and that was the TensorFlow log. Let me now go and show you kind of the same thing, but with the CLI.
So first, let's just go and double check again what clusters I have installed. So I'll run Azure Batch AI, run help, oops. See help, I've got cluster, file server, and job. Cluster, create, delete, get, list, resize. We'll walk through all of those. Let's see what, there we go. Let's just go and look at jobs. We'll go and list the jobs that I have now. Actually, let's go and create a job. We'll do job create. So again, this is the command that we ran first. So we'll create a new job. Actually, change the workflow. Let me go back to cluster. Let's go and create a new cluster first. Batch AI, cluster create, just so we don't forget anything. So the key things I need are, we'll give it a name, we'll call it Ignite Demo. We will give it a configuration file, and we'll use the DSVM JSON that I have. While that goes and runs, let me show you what that configuration looks like. Here I'm specifying what region I want to run in, the size VM that I want to use. Here I'll use the NC6 with 1 GPU. The scale setting is, do I want to control scale manually? I decide when to scale up or down, or do I want to use the auto scaling in a batch, in which case I would express a minimum size and maximum size and the target and the number of nodes that I want to deploy. So in this case, I'll deploy 2 NC6s. Second section is the virtual machine configuration that I want. This is the VM that I'm going to do my training with, or the VM that's going to host my containers. In this case, I'm going to use the Linux Data Science IVM or DSVM, so the offer, publisher, and SKU that you get from the portal, and I'll use the latest version. Next setting is the node setup. Here's where I specify the volumes that I want mounted from Azure Files, from Blob Fuse, from NFS, or a parallel file system. I'm using the storage account name and credentials that I've got in my configuration file, so I can do this without sharing secrets. It creates that URL from that storage account. I'm going to mount a path called AZ files. Finally is the user account that you want created on those machines in case you need to log in for debugging or running interactively. In this case, I'm specifying the name Alex and the SSH public key. Let's go back to here. I see that command was successful. So we'll go AZ Batch AI cluster list output table. And there's the Ignite demo that I created. I see that's the problem. Oh, that wasn't good. All right. Let me just change this. Hold on a moment. That was just actually just setting my secret so I can log in. Okay. So we were at AZ Batch AI, cluster list. Okay, Ignite demo, the nodes were deployed and it's installed, it's preparing the VM. One of the other commands I can do here is change the number of VMs deployed. So let's go to look at the help for a cluster. So I can go cluster resize. We'll go and update the chainer VM and let's call it, let's go from 1 to 2 VMs. So that's going to go, and then if we go and look at the cluster list again, you see that's now in the resizing state. As soon as a VM is allocated, it'll switch to preparing, and then the pool can grow. So from the command line tools or scripts, you can easily scale up or down based upon your need, or ask the system to go and do it for you. Let me go run a couple of jobs and kind of show you a couple of different tools that you can use. First is, let me go and look at what is the IP address of machines on the DSVM cluster so I can SSH to them. And so here I will do, which is the command that I can never remember, so Azure Batch AI cluster list remote login info for cluster DSVM. Actually, let's just put this in a table. So you can see I've got 2 VMs in this cluster. There's the IP address and port. Let me go to an SSH tool here. And I see that all my port numbers changed. Go and connect to that machine. So now I can go and look here. You can see this is the data science VM. So I've got the desktops or notebooks that they install. So this is an example of how it can SSH into a machine that was configured by a batch and work interactively, and with the environment that we set up, you can monitor processes, or maybe I want to go and see if the GPU is actually being used. So we'll run the NVIDIA monitoring tool. Let's go and submit a new job. So we'll go and job create. We'll call it a demo job. Cluster name DSVM. And we use the TensorFlow. Hold on. Go and submit that job. That's going to run, and when that one gets started, we'll see the CPU usage start, or the GPU usage start to grow. Just go job running. deployed, and GPU high. Great. That job runs pretty quickly. Let me show you a good way to access data as the job is running. Let's go and create another job, but let's just call this one TF demo. It's going to go into the queue and run when that first job completed. In the meantime, I'm going to go and grab two commands that is going to go and help me stream the output to new command line windows. So if I gave the job the right name, great. Go and run those commands. Here are these windows, and these will start up, and there we go. Now I see the job ran a lot faster now because the data was already staged. So I've showed a couple examples of how we can go and access the files through storage. We can go and stream the files as well. Great if you want to go and monitor and understand what's going on one of your machines while you're running a job. At the same time, we can also go and enumerate the managed storage for easy. Let me just go and grab the output files. And I can do the same thing for models. I'll just walk you through the configuration for running these jobs. So I have two versions of the same TensorFlow job. So again, this is saying where does it run? The path that I want to configure for this particular job, I want to use where my model data is, where my input data is, what scripts I want to run, how many nodes for this job, and then the TensorFlow job specific settings. This job, because there's no container, will run directly on the host. I've got the exact same job file with one difference is here I added the container setting, which is saying pull the TensorFlow container down. And I just realized that's actually the job that I ran first, which is why the first one took longer to run, is it had to go and download the container from Docker Hub and install it, and then the job ran. Second time I ran the job, the container was already cached, and it started quickly. And that's about it. So I'll just show you one more thing. So again, let's just go to AZ Batch AI, job list, output table. When I want to clean up when I'm done, I can just do AZ Batch AI, job delete, TensorFlow job, and that one will be done. And you can see the lot job was done, and it's terminating. So what I just showed you are the foundations of how I run jobs. There's a couple of ways that you can take advantage of this to do work in parallel. The first are what we call parameter sweeps or experiments. When I'm developing my AI, first step is what's my network? How many layers? What types of layers? How does it work? People do a lot of experimentation there. Second stage is once I have a network that I want to work with, I'll go and run a number of experiments to tune the hyperparameters. This is where you're finding what's going to give me that best balance of accuracy and of performance. Some people do this interactively by submitting a number of jobs. Some people write scripts that go and run jobs with this set of parameters. Work on a couple of things here, some helper scripts that make it easy to go and run, say, go and test these 5 parameters within these ranges and within these steps, as well as taking a look at some of the interesting auto-tuning frameworks and tool sets being developed across the industry, and make it really easy to take advantage of scale. Second part about scale is taking advantage of multi-GPU
GPUs. There's again a bunch of infrastructure work here to set up SSH for communication, set up the InfiniBand pool, launch the MPI job properly. One key point, if you want to take advantage of the RDMA or InfiniBand in Azure, there's a new Ubuntu 16.04 LTS image available in the marketplace now that has tuned InfiniBand drivers for Azure, enhanced networking, and a couple of other kernel fixes. We've done most of our tuning and testing with Intel MPI. We don't support all of the InfiniBand verbs because of how we do the virtualization, so not every MPI stack works on Azure, but we get very good stability and performance with Intel MPI. Another key point is not every framework supports multi-GPU or an MPI approach for communications. This is what allows low latency communications between each of the GPUs, but CNTK and Chainer both do, and both scale really, really well on what we have in Azure. Okay, the last piece that I want to touch on is how we're working with the broader AI efforts at Microsoft. And when I think about what we're trying to do, it's help our customers train and deploy and build their custom AI end to end. The vision is you can take whatever data you have, your private data, public data sets, work with any tools that you want, any framework, any language, working from script, working from Visual Studio, working from MATLAB, go and train in the scale out and scale up way with GPU clusters with Batch, and then go and deploy that with Azure Machine Learning, deploy the trained models into Data Lake, go and use those models however you want. And I think this sort of view speaks to the vision that we have at Microsoft and the evolution of Azure Machine Learning to support both machine learning and deep learning. Is each of the functions can be a standalone thing. We do training really well. There's a team that does data wrangling really well. There's a talk now on operationalizing. You can use those as independent services. You can stitch them together, or you can use the tools that we're developing, for example, in Azure Machine Learning, that will then provide you a nice integrated end-to-end experience. My main point here is around choice. We're going to take care of the infrastructure and do the training really, really well, and make sure that we play well with all the other tools that you want to use. Talk about infrastructure and GPUs wouldn't be complete with just a mention of our GPU roadmap. We started last year with NVIDIA K80 GPUs. That's what drove this interest and excitement in training and the drive to develop Batch AI. We're now rolling out the Pascal generation of an NVIDIA. We have the new NVIDIA P40s GPUs in production now with early adopters, and we'll soon be starting with the NVIDIA P100s, and I expect that we'll continue to work very closely with NVIDIA and bring their latest capabilities to Azure when it's available. The P100s are the NCV2 series. These are really the next generation of the K80 in that they support both double precision and single precision floating point. The double precision very important in HPC and financial services, but both the K80 and P100 are very solid GPUs for deep learning as well. And then I'm excited to announce our first deep learning focused GPU, the ND series, which is the NVIDIA P40, very useful for both training as well as inference. So I want to go and take a trained model, score a lot of data, accelerate it with a GPU. The P40 is great for that. It's also got more memory on the GPU than our K80, which is important for the larger model sizes that we are seeing. We've got a lot of interest in the P40 from both internal and external customers, and this slide is one reason why. In certain frameworks and models, you can get a 2 to 3x speed up. So this is where being able to do things in parallel at scale really pays off, as I can build these larger models and get my research, get my experimenting, get my training done in a much
much shorter time. In terms of the roadmap for Batch AI, we started a private preview in May versus build. I've had some great feedback from customers. You could still sign up if you really wanted to. We're still taking on a few more people in advance of the public preview opening up October 9th. I'm putting down October 9th. It might be that week, but we're on track for releasing the public preview then. That's the ARM provider, basic support in the portal, Azure CLI, and the SDK. This public preview will be open to everyone. And then we're looking at the next set of scenarios that we deliver over kind of the next 6 to 12 months. Probably the most important is being the training target, or being one of the training targets in Azure Machine Learning, and really participating in that life cycle of data preparation, wrangling, experimentation, and operationalizing. There's a whole bunch of different ways that people are using different targets for training. There's a lot of interest in Spark. There's a lot of interest in kind of this batch HPC style training too. Doing work around the easy parameter sweeps that I talked about, as well as one of the other feedbacks we had is, you do great at training, can you help me with scoring and testing too? So that's another use case that we're looking at and saying, well, do we provide another specialized API for that? Do we plug into machine learning? Do we just go straight with batch? Then the final thing is thinking about how you can do serverless jobs. I showed in all of my demos, while I was submitting a job, there was a cluster there already created. You had to go through that step of going and saying, here's what I want deployed. In this region, this number of VMs, this image. I think that's a very common model, because you often don't just run one job. I want to go and deploy my cluster. Maybe it takes 3 minutes, 5 minutes, 7 minutes to set up, do a bunch of work, and then turn it off. We have had a bunch of requests for more of a serverless model. Let me just go and describe my job, describe my resources, fire and forget, and go. I don't want to think about a cluster. In the batch world, we call it an auto pool. You don't have to describe the pool or go and manually explicitly do the pool. We'll take care of it for you. I hesitate calling it a serverless model. It is, because you don't have to think about a server, but there is a server underneath. Particularly when you're using GPU, you want exclusive access to that GPU. You don't want to share it with other people and other containers. But we are taking the feedback of just give me a single API, fire and forget job.